Okay, let's see what we've got here. Over to the right, we have a graph of x to the sine of x. That's this red curve. And at 3 pi over 2, this purple line is the graph of the tangent line to the graph of the red x to the sine of x. And to actually come up with the equation of that tangent line, we need to first find y prime so that we can find the slope of that line. So that's what this is right here. Part 1. Let's find y prime so that we have a formula for slopes of tangent lines. When we got something like this, x to the sine of x, what we have to do is take the natural log of both sides and then apply the power rule for logarithms and move this exponent down front, which is what I've done here. And then when we take the derivative of both sides, on the left we'll get y prime over y equals, and here we have to use the product rule. So we'll take the first function times the derivative of the second, plus the second function times the derivative of the first. And on the next line, I'll replace y prime with f prime of x, and I will multiply both sides of this equation by y, which y is x to the sine of x, so that's sitting out front, times the sine of x over x plus cosine x ln of x. Okay, so there's your formula for f prime. Now, we need to find the y coordinate of the point of tangency, and that's will be f of 3 pi over 2. So here we are calculating the y coordinate of f at the point where x equals 3 pi over 2. This is a -1, which means just take the reciprocal of the base of this power. So 2 over 3 pi is the slope of this tangent line right here. I'm sorry, not the slope, is the y coordinate of the point of tangency, which is about 0.212. Then we have to find the slope of the tangent line at 3 pi over 2, and that's where we plug 3 pi over 2 into f prime. We know that x to the sine of x, which we calculated here, is 2 over 3 pi, and then we've got the sine of 3 pi over 2 is -1 over x, which is 3 pi over 2, and the cosine of 3 pi over 2 is 0. And so there, after simplification, is the slope of that tangent line. So we can use point slope to write the equation of that tangent line. Y minus y sub 1 equals slope times x minus x sub 1. And we can replace y with L of x, the linearization, equals the slope, -4 over 9 pi squared, times x minus 3 pi over 2, plus, when we move this term to the right side, f of 3 pi over 2 is 2 over 3 pi. So there's the linearization of this function. And it's actually just the equation of this tangent line. If I go to board 2, I reduced the focus here of that graph so you could see that when we're close to 3 pi over 2, the tangent line and the original function are very close to each other. That's what we use linearization for. And here's an example. When x is 3 pi over 2, f of x sub 1 is 2.1220. Well, so is L of x. But if I get a little bit away from 3 pi over 2, which 3 pi over 2 is about 4.712, you can see that the linearization is very close, out to the 5th decimal place. Okay, and you can plug in values in this table that maybe are a little bit further away from 3 pi over 2 to see when it starts becoming that the linearization is not that accurate. Okay, there you go. Hope that helped. If you have any questions, post a comment.